start with this proof here, number 3 on proofs 2. And the first thing you want to do is always mark your drawing with the things that you're going to be using to show, in this case, what triangles are congruent. So when we read the proof, up here it says you're given an isosceles triangle, and it says AEC is isosceles. So that tells me that this is congruent to this. So I'm going to use that, but right now I'm just marking my drawing. Does that make sense? Okay, the other thing is it tells me that ABC is isosceles. So I'm going to mark this equal to that. And then I'm reading through and I want to show that BE bisects ABC. So if I want to show that, maybe I write a note to myself. I really want to show, before that happens, since this is supposed to be an angle bisector, I want to show, if I look at this picture, I really want to show angle 1 is congruent to angle 2. So when you do a proof, you do scratch work, just like any other math problem. Because this is going to tell me that BE bisects the angle, bisects angle ABC. So before I do a proof, I always try to think it through, just like before I did a construction. That make sense? So if I had congruent triangles, I could show that, right? And angle 1 and angle 2 are in the little triangles up here, so I'm going to use the same segment property there. Mark that. Does that make sense? Is that too small? You see it?
Yeah. I'm like, what? Yeah, I see it.
Okay.
So there's not a symbol for bisects?
No, there really isn't. I know. I like using symbols too. It's less writing, right? So you're going to go with your statements on the left and your reasons on the right. And, you know, usually you'll just kind of make a little chart. And start. So the purple, you usually start with something in these purple reasons, but not always. But when you look at the picture, you do have some givens. So write down your first given, triangle AEC is isosceles. So you could abbreviate isosceles.
Can you not combine them both?
You can. You can. I'm not going to. Don't combine a lot of things, but that one you could. I'm just going to do it step by step because I want people to be able to make sure they see cause and effect. But since it's the same two things, then you still would go in order. If you combine them, the result combined should be in the right order. So from my AEC, that triangle, that's the bottom triangle, I know the result is that AE is congruent to EC. And I don't even worry about reasons. I get the proof set up because you know what happens if I worry about too many reasons, as I sometimes make a mistake and I have to erase everything. I'm just thinking it through with a pencil and something I can erase with, and I just keep going. So then my third step would be triangle ABC is isosceles. So the result of that is that AB is congruent to BC. And I've got that marked in my picture. Okay. And then my goal is to get the angles 1 and 2 to be congruent, but the triangles have to be congruent first. Jacob.
I was just going to do the last bit.
Yeah, what happens next?
BE is congruent with BE.
So we have BE, and what's the reason for that?
Same segment.
Same segment, right? So even though I'm not writing them in yet, I want to have a plan for them. I just can't write a bunch of stuff down. There is a reason. Same segment. And then what does that tell you?
Two triangles are congruent.
Right, so triangle
ABE and CBE.
ABE is congruent to
CBE.
CBE. And the reason is going to be
7, 7, 7.
side, side, side.
Side, side, side.
Yeah. And then 7 is
Angle 1 is congruent with angle 2.
angle 1 is congruent to angle 2. And the,
CTC.
because triangles are congruent, the parts are corresponding. And so then I can say, if I have my proof statement, BE bisects. So obviously I've got a little crowding here. Oh, but how handy is that? That's going to be my reason. Right down here. So BE bisects, the segment bisects the angle ABC. Okay, so let's talk about reasons. Okay, but before we do that, questions? Yes.
Just a question. So to find that BCE, angle BCE is congruent to angle BAE, don't you have to add a few extra steps because the two angles have to add to the greater angle?
Why would I want angle BCE to be congruent to BAE?
Because wouldn't that be the angle to make it side angle side?
We're just looking at sides.
We didn't use side angle side,
Oh.
so we're trying to stay simple.
Okay, sorry.
Does that make sense?
Yes.
So I know that I have a given, right? This was a given. And the result of the given is a definition of an isosceles triangle, right? If you have an isosceles triangle, then you have two sides equal. So that's not one that I have on there, but if a triangle is isosceles, then at least two sides are equal, right? You just write it out. You write out what it is.
So why would you say? Because you're it's not equilateral triangle. It's also
It's if a circle is isosceles, look, it can't handle that.
0 is isosceles.
If 0, we'll correct that in a minute. That's kind of funny. Okay, so we're going to use that twice, aren't we? Yeah, it's a little fat though. Let's see if I can. I was trying to squeeze that in there so you can see everything. Can I get it better, right? So we'll fix that. So that goes with statement 2, and we'll just cover that circle. It's funny that the computer recognizes something's funny. So this is a triangle, right? If a triangle is isosceles, and I use that twice, and that's why Stephen was saying, can we combine steps 1 and 3? The answer is yes, as long as if step 1 is the first part, then step 2 should be the second part in your result statement. Does that make sense?
Well, I don't get that.
Well, I'm just saying if you made this step 1 and step 3 a combined statement, then if you state AEC is isosceles before ABC is isosceles, then you have to state these two, AE and EC are congruent before you state these two. So you're making an association in order. Order always matters. Well, order matters a lot. Always is probably true. And then for BE equal to BE, that's the same statement property. And then we have congruent triangles, so I'm going to switch to dual page here. And the triangles were congruent by the side-side-side theorem. So we'll bring that over here. And then we have angle 1 congruent to angle 2 by corresponding parts. So I'll blow this up again, but I just borrowed them for the other page there. So can you see that at all? We good there? So we went through and we came up with congruent triangles. You have to have this before you have corresponding parts. Does that make sense? And then, so this is the definition right here. An angle bisector divides an angle into two congruent parts. So since we have angle 1 congruent to angle 2, then we have an angle bisector. Now, I'll tell you, in the old geometry, like old meaning like 15 years ago, and to 30 to 40 to 50 years ago, this would not have been enough detail in a proof. They have a little more detail.
What would you need?
Well, you would do a whole thing about saying how angle 1 and angle 2 add up to be angle ABC. There's a lot more little detail, but it's kind of like getting, what is this, not being able to see the forest through the trees. Now there's a lot more problem solving that's expected in geometry. And so really, it's not as nitpicky. But when I was in college, in like proof kind of classes, this is much more like what we did in a college class. You know, not too nitpicky, but still details. Sky.
So when you're saying, the part I was confused about is like, how you decide which two sides are isosceles. So when you're saying a triangle is isosceles, the middle letter is always the vertex?
That's usually how it's typed. That was a question. That's a good question. Usually how it's typed. This would be the one case if you weren't sure, you would just ask. But usually in your book, not only is it typed that way, but the picture looks right.
Yeah.
So you could ask. You could say, you know, can I assume that B is the vertex angle? So then you know which sides are equal. Does that help? Should do another problem? So let's do this. I'm going to just clone this page and I don't know. Get rid of all of this because I just cloned it. And get rid of all the ink. And let's get rid of all these guys. We'll do another proof. I think I have another picture stored down here. This one. Let's look at number 4. Is this helpful to look at these like this?
Yeah.
So you have a picture of 4, so I'm going to shrink it so we can fit it in here. Okay, so the first couple days of proofs, you have to just sort of make mistakes. And then when we do corrections like this, it's more meaningful. Because you know enough now to correct your papers. So I'm going to read 4, given AB congruent to CD. So I mark my picture as I read. Also, AB is parallel to CD. So instantly that tells me that if this is parallel to this, and this is my transversal, it tells me angle 1 and 2 are congruent. It doesn't tell me anything about angle 3 and 4. Okay, so that's important. So I'm going to just draw over these again so you can see them. So we have these congruent sides, the yellow, these 2 angles, and we're going to use same segment. So I could show the triangle on the top right, triangle BAC is congruent to triangle DCA. And if I could do that, then I can prove the B and D are congruent. This is easier, this one, I think, in some ways. Should we start? First statement, Sky, what's it going to be?
AB equals CD.
Okay, AB, segment AB is congruent. So segments aren't equal because they're numbers. So they're objects, so we say congruent. But, right idea. Okay, and the reason for that is that it's given. Okay, so Alex, what's another one?
AB is parallel to CD.
Okay, so AB is parallel. AB is parallel to CD. And that's a given. So what's the result of that, Alex?
Angle 1 and angle 2 are congruent.
Right. So the result being our third step, angle 1 is congruent to angle 2. Okay, now this is where order matters. What came first, the parallel lines or the congruent angles? The parallel lines. So when I'm going to shrink this up for a minute. When you look at your sheet that I gave you. I'm trying to show you how to use that sheet, which is why I'm shrinking this up here. Try that again. Okay, when you look at your sheet on this side, all these things here, we started with the parallel lines, so we're going to use the theorem that says if you have parallel lines, that's how that's what this means. If you're given parallel lines first, then you know you have congruent alternate interior angles next. Does that make sense?
That's what you would put.
That's what you would put, or you could write it out. Parallel lines result in congruent alternate interior angles. So if you look at your sheet, it says it both ways. Do you see that? So, but if you want to do a little abbreviation because it's same and it fits better, that's what this would mean. That's the symbol for parallel. So parallel lines imply congruent alternate interior angles. Luke?
Can you just write like alternate interior angles?
No. What about them? Yeah, they're nice, they're cute. Sometimes they're equal, sometimes they're not. I know, but that's why, right? Because, do you know, Luke, remember sometimes they're not equal, alternate interior angles, only when the lines are parallel. So it's really specific.
Should I change it?
All parallel lines make? You could. Yeah, so it's just really specific. Okay, so 4 would be, Luke, what would you do next? We're getting there. We have 2 congruence things. AC is congruent to AC, and that's the same segment or reflexive property. Keep going, Luke. What's next?
Triangle ABC equals triangle CBA.
Okay, order matters, right? ABC. So if he starts with A, he has to then do exactly what he said. Go to C. And then what?
DA.
DA, correct. Because of side, angle side, which is also on your paper there. And then number 6. Yeah, finish it.
Yeah, angle B equals congruent angle D because of the corresponding parts of the triangle are.
Right. The angles are equal because the parts of corresponding parts of congruent triangles are congruent. The angles are congruent. How are we doing?
Yeah, that makes sense.
Better? Okay. They get easier even when they get harder because you get better at it.
Like the ones on the other side were harder.
Well, we went over all the answers to those, right?
Yeah.
And they were also new.
Wait, I don't think I remember
No, we didn't.
number 4.
Yeah, we didn't go over before. I thought we did.
We did.
No, well, we didn't really talk about it because that was when we were leaving.
Yeah,
you
had this.
Because that was
Like,
the
we
one,
talked
I
about
can do it now, but I know how to do the rest of it.
Uh-huh.
But
Okay, so I think I have this one right here.
no.
No.
That's like, well, it's
AC
on both sides,
parallel.
it's just like,
That's not,
as long as you have to do that AC equals.
that's it.
That's it.
It's just like you look through.
No. Oh, well, yeah. Okay.
No or yes?
Yeah. Yeah.
That's it, right?
Yeah, except it's.
Oh, the picture's flipped?
No, everything.
No,
It's like if you turn the picture.
No, that's okay. The
The
numbers on the picture.
Whatever, it's fine. It's all the same. It's
That's like
Okay.
this proof.
It's
Thank you.
The 1 and 4, right?
Okay, the diagonal's in a different place. We can just doctor it up.
AB is parallel to CB. But
All right, let's just doctor it up. So you want, thanks Alexis. So it looks like that, right?
Yeah.
Well,
I'm getting there, Okay, so it has an A here, and a B here, a C here, a D here, a 1, 4, 2, and 3. And then what I'm going to do is, I'm just going to give you a quick sketch. I'm not going to write it out formally now. But you should know from the given this. And so the result of that is that these two are congruent. Right? Yes or no?
Yeah.
And then we know AB. So it's pretty much almost the exact same thing as what we did, right?
Yeah,
Except for we're proving something different, right? Well, it's really the same problem we just did, except for the proof statement is different. So what would make more sense is to take the problem we just did and add on. What if I wanted to prove that AD was parallel to BC? I wouldn't use this anymore. That wouldn't help me.
Is you just take out that and you just put on the fact that AD equals BC because of this.
Wait, so.
No. So
could
slow
you
down.
say like angle something is congruent to angle something?
Yes.
TC, and then you say that?
I would have to show angle 4 is congruent to angle 2. 3 was 3 here? 3 by corresponding parts. Because that would tell me, so that would be my step 6. That would tell me that AD is parallel to BC.
Wait, by the opposite interior angle, is 3, does 3 equal 4?
Yes, so I'm going to bring that up here. So now, because we have the parallel lines first, so it's the same order, it's the reverse order, because now we have congruent alternate interior angles in the proof. So look up here. So in this proof, we have congruent alternate interior angles, so now we know the lines are parallel. So that's why I switched the order. Do you see how the order is different here versus there?
Hold on, if you go up,
Well, wait a minute. Let's take care of that question first. This is really important that you understand the difference of these two statements. The order of this is the reverse of the order of this. Because down here, the angle came first. And up here, the parallel lines came first.
Wait, what is AIA stand for?
Alternate interior angles.
That's easy. Yeah, I got it.
Okay? So that's number 4.
Oh, number 7 is number 4. Oh, I got you. I got it.
I modified this problem so we didn't redo the exact same concept over. So your homework is to continue with proofs on that packet. And for the last 13 minutes, I have 2 proofs I want you to write out. So clear off your desks. And Josh, while we're doing that, I'll give you some worksheets. These are not long. They're. Oh, it is still running. How long? So you can always fast forward through these things, right?
Yeah.
Because otherwise they're too long.
wait, this grab